These are notes for section 7.4, solving quadratic equations using greatest common factor. In the last video, 7.4, we talked about factoring polynomials by using a GCF, and we use this GCF, we factor so we can solve. As it says here, we factor so we can solve quadratic equations. Now, we have a new word here, which is quadratic, and I'll explain this in just a minute. In Algebra 1, we spent all semester solving linear equations. We didn't spend a lot of time talking about this name linear, but they were linear equations, and we finished the semester graphing linear equations. And a linear equation simply means that it has an exponent of 1. And we can solve these linear equations by distributing, combining like terms, picking on the little guy, and getting the variable by itself. For example, combine 2x and 3x. To get rid of a times 5, we can divide. X equals 3. Over here in Algebra 2, we have what is called a quadratic equation. And a quadratic equation simply means an equation to the second degree. And the second degree means my biggest exponent in the problem is 2. This is a quadratic equation we have in front of us. And the steps to solve this quadratic equation, 3x squared plus 2x equals 17, is not the same as it is to solve a linear equation. We can't solve it the same way. We have a different set of rules we need to follow to solve quadratic equations, which we're going to get into the rest of the semester. And the way that we solve, or one of the ways we can solve a quadratic equation, is by factoring. So that's what we need to talk about today. We solve a quadratic equation by factoring. Factoring so far we know is a GCF. And we have to use this thing called a zero product property. And that's a very elementary idea, zero product property. Anything times 0 is 0. That is the zero product property. For example, 2 times 0, well, that's 0. 0 times 6, well, that's 0. 0 times -4, well, that's 0. Anything times 0 is 0. This is obvious. We know this, but this very basic concept is what allows us to solve quadratic equations. So the steps to solve. First thing we need to do, it says move all of the terms on the same side of the equal sign. So for example, on number 9, b squared plus 6b on the same side. Next, we need to factor. Factor right now is this thing called the GCF, greatest common factor. And once we factor out the GCF, we need to set up two equations, both of them equal to 0. And a quick look ahead here, two equations or two terms, two numbers, both of them equal to 0, or set up two equations equal to 0, two things equal to 0, and then we can solve. For example, on number 9, the GCF between b squared and 6b is b. That is the GCF. What's left over would be b, because b times b is b squared, plus 6, because b times 6 is 6b. This is now factored. And what we have done is taken a quadratic equation, and again, this quadratic equation means that it is b squared. And I've taken this quadratic and I've made it into its two linear factors. Linear factors meaning they have an exponent of 1. B and b both have an exponent of 1, and b times b would be b squared. So now that I have the polynomial factored, my next step is to set up two equations, both of them equal to 0. So I have the stuff on the outside, b equals 0, and I have the stuff on the inside, b plus 6 equals 0. And then I need to go through and solve them both. And this quadratic equation has turned into two linear equations, which we should be comfortable solving. In fact, the first one is already solved, b equals 0. And the second one I can solve by getting rid of a plus 6. I can subtract, and I get b equal -6. So I get two answers. both of them making the equation true. On number 10, the GCF between 10 and 35. Well, that would be 5. 5 goes into 10 and 35. They both have an n squared or an n, so the GCF is 5n. Once we have the GCF, I set my parentheses and I need to work backwards. What times 5n would be 10n squared? Well, that's 2n. Plus, because it's a plus sign. What times 5n is 35n? Well, that'd be 7. 2n plus 7. From here, I can take my two linear factors and set them both equal to 0. That is to say, the stuff on the outside equals 0, the stuff on the inside equals 0. And this is applying the zero product property. If I can get one of these two things to be 0, the whole thing is 0. So to get rid of a times 5, I can divide, n equals 0. And on my second linear factor, I can subtract 7, divide by 2, and that's n equal negative 7/2. Again, I'm going to get two answers for these quadratic equations. Let me do two more for you. On number 11, x squared equals x. I'm not ready to factor because I don't have all of the terms on the same side. So the first thing I need to do is get all of the terms on the same side. So I subtract x. Now that I have x squared and x on the same side, I can factor out the GCF. The GCF is x. What's left over? What times x is x squared? Would that be x? Minus, because it's minus sign. What times x is x? Well, that'd be 1. X times 1 is x. Once I have factored, I can set up my two linear equations. Both of them equal to 0. The first one is solved for, x equals 0. And the second one, to get rid of a minus 1, I can add 1. And I get two answers. Last one on number 12. Again, I have a quadratic equation. To solve this, I can factor out a GCF. The GCF between 4 and 2 is 2. Between x squared and x would be x. The GCF is 2x. Now I need to work backwards. What times 2x is 4x squared? Well, that'd be 2x. Plus, because it's a plus sign, what times 2x is 2x? Well, that would be 1. 2x times 1 is 2x. Once I have it factored, I can set up two equations. Both of them equal to 0. On my first equation, to get rid of a times 2, I can divide. And on my second equation, I need to start by subtracting 1 and dividing by 2. And again, you're going to end up with two answers, negative 1/2 and 0. Hopefully that helps. I'll see you on the next one. Thanks. Bye.